President of the August South African Institute of Electrical Engineers, Mr. Andre Hoffman, Deputy President of the Institute, Mr. Marikane, our distinguished speaker of the day, Professor Saurabh Sinha, members of the Price family, with whom this university has a long record of close collaboration through various initiatives that they have initiated at Wits throughout the years. It gives me great pleasure, on behalf of the Vice-Chancellor, to welcome you all, ladies and gentlemen, to the 64th Bernard Price Memorial Lecture. This morning, we are all shocked by the crime statistics, which somewhat have bucked the trend over the last 10 years. We have been inundated by news of lack of South Africa's performance with mining industry, showing major areas of strain. Our manufacturing is going under a lot of pressure, and basically all vectors are pointing south. However, at this morning's meeting, I happened to have met the Deputy Director General, the Director General in the Presidency, who gave us statistics that came out of the World Economic Forum, which does the global comparative report from Davos, or Geneva rather, but they have an annual meeting in Davos, Switzerland. WEF does this every year. They look at the competitiveness across the globe. Of course, Singapore, United States, the usual suspects are at the top, New Zealand and Scandinavian countries. And the laggards, obviously, need no mention. Venezuela and so on and so forth. And South Africa hovers around the 50 area with, BRIC countries, India, China, and so on and so forth. And although Brazil, of course, is also not doing so great. And lo and behold, South Africa jumped about 7 places to the top 50 from a vector that has been pointing in the other direction. And it's not because, of course, of governance issue. That was actually our area of weakness. No surprises there. Our strength was in innovation, technology, and research. And I think this lecture today is an exemplar of the achievements that our researchers, our industrialists, and our technocrats are putting their shoulders behind the wheel to ensure that we, like Sisyphus, keep on rolling this boulder up the force of gravity. Hopefully we don't do it every day, because that's quite a punishment. But certainly, I think this lecture that will be presented today will again elucidate the level of quality of world-class research. This would not have taken place without the support of appropriate learned society, the Institute, Mr. President, of Electrical Engineers being one of them, supporting many other initiatives. So in that regard, Wits is indeed very proud to host this, what I've been led to believe is the apex lecture of the year for this very august body, the Bernard Price lecture, to be given by Professor Saurabh Sinha. On behalf of the Vice-Chancellor, I welcome you all to this lecture, and I'll hand over to the Program Director. Thank you very much.
Thank you, Professor Vilakazi, for that very nice welcome. On behalf of the SAIEE, I also welcome all of you. On behalf of Council, and of course we have a new Gauteng Centre now, and we're in Gauteng, so welcome on behalf of all of them. There's many past presidents I see here, and some incoming presidents as well. And Michael, the nephew of Bernard Price, is here. Welcome to you, sir. It is indeed a privilege for me to take on this role as president this year. 100 years ago, it was none other than Bernard Price in 1915 that stood, not at this lecture, or possibly certainly not at this lecture, but he was leading this institute 100 years ago. And as you can imagine, South Africa in 1915, a very different place. The institute, 6 years old at the time. A lot of his young engineers were called to duty and he had different problems to face. It's good to see so many young people here. There's a blend of people. I've noticed this is the 6th lecture we're giving in this particular series, and there's a nice blend here tonight of older and younger in this particular lecture, and we're particularly focusing on you young guys and girls, because this is part of what we've called the Pay It Forward campaign. And when I called on Professor Sinha to step up and take on this role, he did it admirably, and you'll see from his talk tonight. You'll see at the entrance there's some little brochures like this that we've prepared for you. They're quite nice. On the one side you've got for the electrical engineer, and on the other side, the flip side, it's for the school leaver. So these are just some information brochures. I have to pay the piper, so you can see what we're about as an institute and how we can help you, particularly students and graduates in your careers going forward. So today is the 30th of September, and I'm very glad that we made it, because as you all know, the world was supposed to end about 2 or 3 days ago. Something about the blood moon prophecy. But I think whatever the guy was smoking when he made that prophecy, what he actually saw, I think, was the Japanese flag, and the world ended a weekend or so ago. But it's back on track, so don't stress about that. This lecture is the 64th in a series starting in 1951, but even before that, it is a great tradition between the University of the Witwatersrand and the SAIEE starting back in 1931. The centenary of the discovery by Michael Faraday of electromagnetic induction, which resulted in a joint meeting between this university and the SAIEE. And then 20 years later, it became known as the Bernard Price Memorial Lecture in honor of Bernard Price, who, as you know, had a great impact on South Africa, not being born here, but certainly left a legacy which we're all benefiting from. So to introduce the speaker tonight, now I've done this 5 times, but his CV is substantial. I've decided to change it a little bit tonight and tell you about Professor Saurabh Sinha by the numbers, okay? So 1, currently the number of PhDs that he holds. 2, the number of degree distinctions that he achieved in his bachelor's and master's degrees. 3, the number of books he is currently leading the authorship of, 2 of which in the area of millimeter wave microelectronics, power amplifiers and antennas, and 1 in the area of microsensors for sustainable development. 6, the number of times he's adapted his presentation for the audience. We're going to get that one tonight. 10 plus the number of years he has served the University of Pretoria, his last service being as director of the Carl and Emily Fuchs Institute for Microelectronics, Department of Electronic and Computer Engineering. It's a long title. 64, this is the 64th Bernard Price Memorial Lecture, and he is the appointed lecturer for this one. 85 plus, that's the number of publications in peer-reviewed journals and at international conferences that he has authored or co-authored. He has a day job, actually. He is, since October 2013, appointed as Executive Dean of the Faculty of Engineering in the Built Environment at the University of Johannesburg. And for the rest of his time during the day, he spends on voluntary appointments. And these are some examples. He is the managing editor of our own South African Institute of Electrical Engineers research journal, the Africa Research Journal. He serves as a volunteer of national and international professional or statutory organizations such as EXA. Significantly, he is also the 2014-2015 Vice President of the IEEE Educational Activities and IEEE Board of Directors. Some of his awards and recognitions: 2007, receiver of the South African Institute of Engineers Engineer of the Year Award. And by the way, we're looking for nominations for that for our annual banquet. So members, please put your hand up or nominate someone to be in the same prestigious group as Professor Sinha. 2010 University of Pretoria Laureate Award. 2013 T.W. Kambule NRF NSTF Award for outstanding contribution to science, engineering, technology and innovation through research and its outputs. He is a fellow of the SAIEE and the South African Academy of Engineers and a senior member of the IEEE. Let's welcome Professor Saurabh Sinha.
Ladies and gentlemen, I'm starting to get worried when Andres said that he's going to change my CV, because it is not always easy to make these changes on short notice, especially the PhD one. Okay, So I'm in a difficult territory here today because I do work for the University of Johannesburg, as you've heard. So I know that, so I was thinking about what logos to add, but I knew the WITS logo is going to be right behind me. So I'm very pleased to be here, and it's also a very important topic, I believe, and it's a topic that I'm quite passionate about. It's a sustainable engineering education. And when we started talking about this topic, it was about just over a year ago, when Andres said we need to have a topic that will have relevance to the fact that this is the 2015 Bernard Price lecture, and the vision of Dr. Price needs to come forward in some of the thinking. So, of course, when you propose a topic, it looks something like this, and it has the potential of some level of ambiguity. So there's the sustainable engineering education, which is perhaps why half of you are here, and perhaps the other half of you are here because you thought I was going to talk about sustaining engineering education. But I will try to have both of the talks, because I realize that there are a number of academics here and you would like to get the sustainability component in engineering education. Nonetheless, this weekend that passed is an important weekend because it's the weekend when the Sustainable Development Goals were discussed, debated, and adopted. And this was after 15 years since the Millennium Development Goals were formalized in September 2000. And as you can imagine, the timing was selected very carefully because the world could have ended, as you have heard earlier. So it was done in case the world doesn't end, then there will be an opportunity for the next 15 years to implement the Sustainable Development Goals. The Millennium Development Goals that were discussed in September 2000 were implemented for the last 15 years. There were 8 goals, and one of the goals was to eradicate extreme poverty. So to define extreme poverty is a person who lives under $1.25 a day. So extreme poverty, so if one looks at the data and one compares what has the world achieved regarding extreme poverty over the last 15 years or more, the world has in fact been able to halve the number of people that fell in this category. South Africa too has had an achievement in this regard, resonating to what Nelson Mandela has said, that poverty is not natural, it is in fact man-made, and it can be something that man can change. So if we look at the other goals, and if we look at, for example, the goal on achieving access to clean water and to access to sanitation, once again, the numbers show that the world has had an achievement in this regard, that the people that have access to clean water today is double what it was at one point, such as 1990. So there has been a tremendous achievement in this regard. However, if you think about the Millennium Development Goals, the Millennium Development Goals were very much around achieving the 50%, let's improve by 50%, let's double the number of people that have access to clean water. But it was not, the emphasis was still on numbers such as 50% improvement. Now, the question is, are we there yet? The answer is no. There's still poverty to deal with. There's still clean water to get folks to. The Sustainable Development Goals that were formalized deals with a number of these Ps, which stands for People, Planet, Peace, Partnerships, and Prosperity. In the talk that I present, I try to encompass these P's. The Sustainable Development Goals, there are 17 of these Sustainable Development Goals that were adopted in New York over the Sustainable Development Summit that took place last weekend. Incidentally, the UNESCO also held Africa Engineering Week at Mangosuthu University of Technology, and some parameters that they brought about are parameters that I covered later on. The Sustainable Development Goals, of which there are 17, brings back some of the Millennium Development Goals, such as no poverty, such as the issues such as zero hunger, such as climate action. Back is the item on clean water and sanitation. But we know that today, that the way that we do things, it can't be without partnerships. So partnership also falls as one of the Sustainable Development Goals. So, but there is one difference. When you saw the Millennium Development Goals, you saw that there was emphasis on the number 50%, let's halve, let's double. The interesting part about the Sustainable Development Goals is that it talks about let's end poverty in all its forms. Let's get water, clean water to everybody. Let's leave no one out. So that does change the picture quite a bit. Now, the word all is like a three-letter word. The trouble with this word is that if you look at water, for example, in 1990, 43% of the world had access to clean water. In 2015, 57% had. So this was a Millennium Development Goal that was in fact achieved. But if you look at the word all, when you move from 43% to 57%, then you move from 57%, all means 100%. So you move from 57% to 80% or 85%, then 90%, and then 100%. And when you start going towards the last numbers, folks that work in the area of telecommunications, that's also a challenge that goes there to how do you get communications to the last person. And that last person that issue is called last mile, is denoted as the last mile ahead, the last mile challenge. The last mile is one of those miles that's possible, it's achievable. This is, however, a problem. The problem is to deal with this figure that looks like an 8, otherwise called infinity. The last mile sometimes requires this infinite budget. If any one of you has access to such a budget, please let me know. There are a number of universities, including WITS, that may be interested in engaging with you. So the question is, what do we do today that enables South Africa to be in the Victory Lab, that enables African countries to be in the Victory Lab in terms of Sustainable Development Goals over the next 15 years? I'm going to go into some context on Sustainable Development Goals. Sustainable Development, the context in terms of numbers that contextualizes engineering figures. Some of these figures were also repeated at the UNESCO Africa Engineering Week that is going on, that is actually concluded today at MUT. These numbers, which have been previously also published by the Consulting Engineers South Africa, the Engineering Council of South Africa, gives you a rough figure of the ratio between technical and non-technical persons. In a country like South Africa, this number is about 1:3,000. In the developed countries, one finds figures in the range of 1:300. So for South Africa to become competitive economically through engineering, we require, in fact, a tenfold, I wish it was 10%, a tenfold increase. If you look at other African countries, these numbers are, in fact, gets worse. It looks like 1:6,000. So a second issue that has been published by the African Economic Outlook is a second challenge, which is the challenge of that when there are graduates and what industry looks for in these graduates, there is a disconnect. So one could argue and say that universities don't produce engineers, but produce candidate engineers, produce graduates in engineering. But there's not always a bandwidth and opportunity for mentorship. There is a scarcity in that zone. So therefore, there is a disconnect, and I will just leave it at that, and I'll come back to it later. If you look at the scarce skills list, for example, published May 2014, and you look at the 100 most scarce skills in the country, one finds that a number of professions that deals with engineering technology, that deals with built environment, and some of the IT disciplines, they tend to feature heavily in the scarce skills list, which is not necessarily a good thing. It's not a good thing. Being popular in this list is not good. So obviously, the one way to address this is to deal with the pipeline and to expand the pipeline. The pipeline is referring to the pipeline of students that are interested in disciplines which are considered to be scarce. Trouble is that this is maybe how the pipeline should look. The reality is that it looks something like this. And so if this is the pre-university pipeline, it means that a number of students that are eligible for engineering top programs in the country are in fact quite limited. In fact, if one looks at it, and I know that the entry criteria varies from university to university, but this number is as slim as 14 to 20%, depending on the program that one enters. So it's a fairly small number of students that are in fact become eligible to do engineering type programs. So of course, industry comes to the party and helps to bring some level of bridging, some level of additional avenues to extend the pipeline. So that is one way of dealing with it, is the pipeline issue. The trouble with engineering is that when you go to a high school and you talk about engineering and you tell a student, how about, you've done well in mathematics and science, maybe you're a candidate for an engineering program. They look at you, they get very worried, and they think, did you see a geek in them? Do you think that they can do geek and Greek? And so there's a perception issue, and is it a scarce skill or is it a scarce skill? And that comes up. So this is another image that some of you may have seen, is what we promise students before they join is a program like this. Look, it's a 50% female population in this group. Reality is a little bit different. Some sort of coffee that is included day and night. So we end up having a scenario, but we know that if you save an engineer, you save the world. So the next thing is that if you look at the perception, the public perception of engineering, it's also somewhat worrying. And the good news is that sometimes if you want to feel good, you look at other people that are not doing so well. So the United States has a similar challenge. In fact, the challenge is to the point that it decided to change the conversation in terms of developing the public perception, developing the public understanding and appreciation of technology, something that is achieved through engineering. When we think about engineering, if you think about engineering in between 1900 and 2000, you think about the world wars. You think about the impact of computing, impact of communications. Yes, that's important. But you think about other effects, such as if you take lifespan as one example, and you look at a person's lifespan in 1900, let's take the US as a reference. In the US, the lifespan in 1900 was about 46. In 2000, the lifespan was about 76. So the lifespan changed, and it changed considerably. And it did so because there's access to clean water. And that was an impact that engineering made. So it starts changing the conversation that engineering is about the impact of the profession. At a number of institutions in the country, engineering programs today receive some components that deal with humanities and social sciences. So you may go to a university and you may find that an engineering program has a course such as psychology for engineers. But if you think about it, we don't have a program that deals with engineering for psychologists, engineering for humanities, right? If you think about the role that technology plays, we probably should have a course that is a basic citizenship course for all students on engineering. So changing the conversation, this will start to get us to change the conversation. And this was part of the text, among other suggestions, that was published by the National Academy of Engineering in the United States. Going back into our depressing figures, if you look at figures around some of the disciplines that Professor Vilakazi mentioned earlier on, and you look at these numbers of graduates in Africa, and particularly in disciplines of engineering, manufacturing, and construction, one finds that the numbers of graduates is really thin according to the African Economic Outlook. If we, however, look at these numbers for South Africa, and if you see some of the figures, of the number of students in a system, enrollment versus graduates, this is across engineering technology disciplines, one finds that the throughput has, in fact, the graduate, only 14% have graduated of over 500,000 that have come in the system. I was giving a presentation like this at another university a few days ago, and one of the students rose their hand and they said, well, you know, I'm still around, it's my 7th year, so part of some of, you know, I'm getting there. So that is there. But what you realize is that there is another leakage. There's another leakage that happens in the system at the university. My talk today is not looking at the pipeline. My talk today is looking at what happens at university. Perhaps because I work at university and I can see a number of colleagues here that also do, I believe that we have an ability to make some changes in the university system. Perhaps we can also do others at the pre-university levels. Again, to feel better, you have to look at news that is not good in other places. So looking at some data from the American Society of Engineering Education, figures from the US, and I zoned in electrical engineering in particular. In the US, there's also a difficulty in recruitment, and the number of students interested in disciplines such as electrical engineering has in fact been on a decline. Whereas other disciplines such as mechanical, such as civil, has been on an upward trajectory. My talk today doesn't specifically deal with electrical engineering, but I thought I'll bring in this slide with the relation with the South African Institute of Electrical Engineers. So there is the pipeline issue that developed countries also face. So now I'm going into the first version of the talk, which deals with sustainable engineering education. And good engineering presentations must have multiple graphs, and some of them must have a nonlinear behavior. So I decided to bring in this particular chart because it's a chart that represents you. And it's a chart that represents when we, as academics, deliver classes in a conventional classroom setting. So if you think about this, if you're not familiar with these waves, you should be worried. These are brain waves. And these measurements were taken, and if you look at some of these measurements and you look at some areas on this graph, such as the area the areas which may be somewhat flat, like those areas over there, then you think that that might be a period when the individual is at rest, and perhaps you're right. You look at another zone like that and you think that, you know, maybe this person, maybe over here there was an exam activity or you know, there was, you know, you get the idea that some activities are more peak than others. So you continue looking at it and you think about class, right? You think about class and you look at where you know, it's not a very classy situation, unfortunately. You do see it in the dead zone. So you zoom out, and when you zoom out into this, then you see this looking something like this. And this work was published by Dr. Mazur from Harvard University, and you notice that the classroom zone. So I know that a couple of you are from industry, a couple of you are from academia. So to the academics, maybe the scenario you're dealing with looks like that. Look, there's a couple over the desks as well, the cupboards. So look at this and keep this in mind. Might be happening. It might be a reason why we have some leaks in the academic system. May not be the only reason, there may be others, but it may be one of the reasons. So sometimes if you look at a classroom environment and sometimes what the environment has been, you know, what the curriculum has been requesting, what the students have been needing, what administration has ended up implementing, and as a dean, I often realize that we have sometimes done that. As an assessor from an accreditation point of view, you sometimes think that's what the accreditation bodies want. But this disconnect sometimes leads to a misalignment, and some of these misalignments end up featuring in very expensive projects, sometimes requiring an infinite budget to fix. So I bring about a quotation from Lindemann, and when I was looking at this quotation, I thought about, you know, some of the vision of Dr. Price. And when we think about presenting engineering programs, we often think about modules, we think about modular, we think about subjects. And Lindemann's presentation doesn't talk about subjects, it talks about scenarios. It talks about educational possibilities for the everyday life. It talks about people's experience and learning through such experience. I'm now going into the other part of the talk, the sustainable engineering education talk. So when we think about sustainability, I often like to think about sustainability and in terms of the three pillars, social, environmental, economic. Sometimes it's a little difficult to remember, so you could remember it probably as SAIEE, or you could remember it as PET. I like to think about it as a PET. PET standing for people, economics, and technology. When we think about technology independent of people, we're thinking about creating problems, not solutions. And of course, it needs to have a good governance model. So when you think about this, when you think about the economic component, and I'll come back to the economic component because I don't think we think about it enough. So this talk proposes some changes into not necessarily only the component of curricula, but of pedagogy, of andragogies, recognizing the development that has happened independently in how we know and what we know about how people learn. We know that our students today are very different to how they were in the past. They have a lot more information. Their attention span may be somewhat shorter. Maybe they're shorter because of the influence of this device, the mobile phone. So we look at some examples of frameworks that could, in fact, enable sustainable engineering education, and one of those frameworks deals with engineering projects in community service, a model called EPICS. We also look at technology-oriented solutions, and I'll try to present some example around that. And I am not going to be able to go into this zone, but I don't want to leave you with the feeling that I put down an acronym here, and if you pronounced it, you would hear cows. MOOCs. MOOCs is another important concept, massive open online courses, that's what it stands for, is an important element in the way that learning could be further enabled today and complement what we do. I decided to put an e-learning, the electronic-based learning, and m-learning, mobile-based learning, and I decided to put it as two separate terms, just to remind us that the way that we engage with a mobile phone is not for a long time, it's for a very short period of time. And sometimes when we think about mobile learning, we think about it like e-learning. And we think about designing tools which are compatible with a mobile phone, forgetting how differently we engage with a mobile phone compared to an electronic platform such as a computer. I'm going to go very, very briefly about my life journey. Fortunately, Andre has done a good job with the CV. I served the University of Pretoria for some time, and then I moved over to the University of Johannesburg. It was interesting to me that universities, including the University of Witwatersrand, has a very strong component, whether it is in its vision, whether in its purpose and mission statement, that there is a component of the African soil. There's a component strongly emphasizing local relevance in addition to being globally competitive, and perhaps not seeing the one disconnecting the other, but seeing how local relevance could in fact become an enabler for global competitiveness. In this context, I had quite a bit of influence, or I was influenced in the way I thought through an organization called the IEEE, which has a National Society partnership with the South African Institute of Electrical Engineers. The IEEE went into a change over the last 15 years, and an important change was in its tagline. The tagline moved over to advancing technology for humanity. Sometimes when I'm addressing audiences that have a student component, they often tend to read it as advancing humanity for technology. It's the other way around. And what engineers really do is to connect technology with people, and in this way, advance technology for humanity. I want to recognize a couple of individuals who were instrumental in some of the thinking around engineering projects in community service, starting from Lee Jameson, who serves as a Dean of Engineering at Purdue University, and she also served as a former IEEE president. In fact, 5 of the 4 that are in this picture are former IEEE presidents that became very instrumental in shaping the organization's tagline in terms of advancing technology for humanity. Moshe Kam, Kapil Dandekar, Mike Leitner, some of these individuals have been to South Africa. Lou Thurman, interestingly enough, Lou's the son of Fred Thurman, a former dean of Stanford University, and it was almost natural that there was a lot of thinking of his dad in the approach, but also shaped independently by the work that Lou Thurman did. He, among others, led the humanitarian committee within IEEE. I ended up, for some works, becoming an IEEE vice president, which gave me the opportunity to expand this initiative and a number of others around the world, and of course to bring some of this thinking into the way things are done back in South Africa. Sustainability, so I'm going to cover this by way of an example, a notion of EPICS, engineering projects in community service. And so this framework really works by recognizing that partnerships are important. So partnership is really at the center of this business. You could think about it as engineering partnerships, not just engineering projects. So it recognizes that non-governmental organizations and non-profit organizations are already working with communities. But you could replace non-profit organizations with other entities such as municipalities. And it also recognizes that universities tend to deal a lot with pre-universities. For example, we recruit from the pre-university tier. It's important that we have students that are well prepared to pursue different careers in a university environment. So universities have a partnership, therefore, with secondary schools. And the question is, can we take this partnership and map it into what happens with non-profit organizations? And if we do, how can this partnership end up benefiting communities? And how can the community be a recipient? Of course, there's an interesting component that I think of as vertical integration. I was very worried when I was preparing this presentation that there were no equations. So I decided to have the integration sign. Anyway, it's not a stretch S, but there's a stretch there which actually says that secondary school students aspire and are inspired by those that are at universities. And similarly, university students are inspired and aspire towards new aspirations by those alumni that may be part of municipalities or other partnerships that they engage with. So vertical integration is an important component that this builds. It also builds and brings about other external sponsors who may be engaging in kind, such as corporate social responsibility, or it may be in cash, or it may be in time that they spend in mentoring some of these projects. So the EPICS component can be in 4 different areas, broad areas of access and abilities, education and outreach, environment, and human services. In the example that I present today, I will cover the instance of environment. A number of years ago, I had the challenge of trying to cover a topic in curricula. I used to serve in the domain of electronic engineering. And one of the things that came about was the National Air Quality Act. And the way that National Air Quality Act, so if you can imagine an act, you're probably thinking about these documents with lots of text in black and white, these documents that have the ability to bring down the EEG signals to really a very dim value. It's very difficult to try and train students on components of the law of an act, but nonetheless, it's important to do so. So if you look at aspects of the Air Quality Act, among others, there is an aspect of measuring pollution in concentration per cubic centimeters. And the way that it tends to be done conventionally is that there are fixed stations, and these fixed stations are typically represented by those bigger hexagon symbols. And so this may be over a particular area, and you do the measurements. So the thought was, how do you enthuse electronic engineering students to engage and understand and implement aspects of the Act? We know that in many emerging economies, we have good acts and plans, but we're not always able to implement some of these plans. So in this example, the idea was to actually have decentralized mobile stations, which are like cell phones, which then get connected in a format such as this one. I'll get to the format just now. So the mobile devices are, you can imagine your mobile phone that gets connected to sensors, and then you have enough of these that may be active, and by way of probability you can come to some kind of a deduction on whether, say, a pollutant threshold has been exceeded. So in this particular initiative, we had a number of partners, Copperbelt University in Zambia, because they also have environmental protection issues with a couple of mines that are in the area. University of Pretoria, University of Johannesburg came about when I joined the university. St. Albans College, which was a secondary school, and I'll come to that in the next slide, was an important partner because this was about vertical integration. So it was important to bring about the notion of early professional development to the university students by them actually practicing some of what they have learned with these pre-university groups. So moving on, the secondary school that was involved had a couple of students that were involved. There were 8 students that were involved. So it was a small initiative, and most of those students became part of engineering programs later on. So it did deliver from that perspective, and that gave me some more reason and freedom to work with these students. So essentially, I've given you the picture. You have a mobile phone, gets connected to an input-output device, initially through a cable, through a USB cable. It gets connected to a sensor. So we had different type of sensors. So we did a similar initiative at the university level where a fourth-year student was involved in designing the board, and he dealt with gases such as sulfur dioxide, with nitrogen dioxide. But the school students decided to just work with smoke. By the way, as a joke, one of the students reminded me from the St. Albans College that this was boys' school. And if we dealt with smoke sensors, we'll probably find the smoke. So anyway, so initially we started with a USB-based implementation, cable-based implementation, and it moved on. The next iteration, the students realized that if you take a mobile phone connected to sensors and you leave it in a classroom, as you know, in Johannesburg, we call these devices mobile devices, and we call them mobile because they have the ability to move. And sometimes they leave us. So they very quickly realized that the next iteration is needed, and they moved on to a wireless-based solution where the devices were decoupled, the sensing and the communication got decoupled, but you could see an iterative approach started to happen, which is exactly what we intended. So this is the picture around the carbon dioxide, and there was some programming that was involved. And it's always difficult to train students in programming, but it was not too difficult to train them in mobile-based programming because it has something to do with impact. You can see an image here of the students practicing, very engaged. The university student had a much more complex project and had to do an implementation based on first principles. So one could have different levels of engagement and different levels of engineering education through this. You can see some further pictures that shows how the thresholds that were exceeded were caught up. In another iteration, the students realized that these devices get power hungry, and it's important to look at other elements of other ways of powering, such as energy harvesting, and it goes on. Other editions of the EPICS initiative is on access and abilities, and here you will see some pictures. And the EPICS project expanded to different parts of the world. This is from India, where you can see that students had a vision of assisting differently abled individuals, and they did so by imagining how a vehicle could look, and they ended up implementing and realizing their imagination in what they call the green cart eventually. And you can see again that there was a lot of hands-on activity that went into this initiative. Another example of a project in education outreach where the Copperbelt University engaged with students who had no direct access to educators in their school. So they decided to bring in the educator by way of computer-based training and some interactivity that they established through communication. Initiative expanded pretty quickly, as you can see, in different parts of the world, over 50 projects in 15 countries. And what was interesting was that students or volunteers who are unusually present in many engineering programs, such as female volunteers, they're very engaged in this particular initiative. I'm going to take a slightly different tilt to my talk now. I'm going we'll together travel the world, starting with the West Coast in the US at the University of California to give us a picture of what's happening in the other parts of the world. University of California, Berkeley, one of the top schools, emphasizes some of the elements of their vision. Interdisciplinary is emphasized, serving society is emphasized, community and entrepreneurs is emphasized, technologies that can save the world is emphasized, making things or make them better. Some unusual modules in their electrical engineering program, which you don't see very popularly in many electrical engineering programs in the country: embryonic development, interfacing with the mind, protein networks, engineering for developing world. Still, University of California, parallel universe, mechanics of organisms, robotics is maybe becoming more common. Working in teams was very heavily emphasized. Looking at another university, still in the US, Stanford, seeking solutions to important global problems, leading to making a world a better place. Emphasis here is not just on graduating engineers or graduating engineering technologists, but graduating some who are leaders of engineering, innovation, pivotal technologies, thousands of companies, of course, resonating strongly with Stanford, where it's positioned, technology transfer, spirit of entrepreneurship, mobile app development, startups, looking at curricula that deals with forces of nature. Still at Stanford, a lot of hands-on activities, starting right at the freshman level. Electrical engineers teaching physics, that was interesting. We don't always find that. In fact, there's usually that ends up in a conflict. Building was emphasized. DNA microarrays were part of the array of modules that they offered, microfluidics, but not at the graduate level, at the undergraduate level. Mechatronics, moving some other examples, in vivo imaging, in vitro diagnostics, neural prostheses, underlying physiology, emerging biosensors, green electronics, moving on to MIT. Exceptional community educating engineering leaders comes up. Math, computation, physical life sciences, biomedical engineering, biomedical sciences comes up quite a bit in most of these institutions. Rigor and innovation, hands-on again comes up, hands-on curricula, emphasis on flexible. In fact, they have flexible PCBs, they are glucose sensors, and oddly enough, the electrical engineering program is, you can also graduate in a program in computer science and molecular biology. Perhaps that's quite flexible. Some unusual undergraduate courses: evolutionary biology, computational biology, machine vision, not just human intelligence, not just artificial intelligence, but human intelligence, enterprise. Moving on to across the Atlantic to Eth Zurich, another top institution, about results into practice. Their research themes very much have the flavor of the Millennium Development Goals: world food systems, cities of the future, climate change, energy, health, risk, research, information processing, new materials. So you can see that this institution very quickly said that the Millennium Development Goals, like Sustainable Development Goals, will stay where they are unless universities adopt and adapt curricula to implement such. Going to the east, in Asia, Tsinghua University, universities in China today, if you look at, for example, in engineering, citations per publications, that is one measure of publication impact, one finds that Chinese institutions are really taking lead. Emphasis on social commitment at Tsinghua University. Students educated to be leaders, and one also notices the influence of contribute to civilizing China and the world. Of course, China is a world on its own, But that resonated with me on some of the visions, the missions that universities in Johannesburg have that deal with anchored in Africa, or that deal with the African soil, the locally relevant components. Some examples of how the university, Tsinghua University's Department of Electrical Engineering has evolved, has given birth to other departments and disciplines. 1932, electrical engineering; 1970, automation; 2001, biomedical engineering. So these are some children departments of electrical engineering. And some of the programs, and I highlighted the one in electricity market. I had the chance to speak to some graduates. So I've been at multiple universities, so don't try and guess which one. And I was speaking to some of the graduates of civil engineering firstly, and when I spoke to them and I said, do you guys know what the cost of water is per liter? And it stunned me that a number of students had no idea. Right, so I said, what about cost of electricity? What about kilowatts hour? Have you any idea about rents per kilowatt hour? I realized that we've taught them just kilowatts, we've taught them watts, we've taught them volts and current, but they're not always current about the unit, but the cost per unit. So the cost per unit starts to bring in the economics component into an engineering discipline. Some other unusual components in the automation, not just the control and optimization techniques, but recognizing IP networks in the context of Internet of Things, roaming over filtering, moving over to Hong Kong University of Science and Technology, also a number of changes there towards our next miracle is what they have. They have gone beyond engineering to Engineering Plus, that's what they call it. I wonder if it's their aim to become an A+ institution, probably. Plus in this case stands for preparing leaders for ultimate success, and one sees notions of humanities and social sciences. But they have broad programs that are not only looking at graduating engineers, but are looking at graduating leaders of engineering. Working closely with Institute for Advanced Studies, broadening research and having a greater component into undergraduate education. That's probably something that we are also doing in South Africa. Courses, some unusual courses, ecotronics at Hong Kong University of Science and Technology. So I don't know if you saw that. I went quickly through a number of slides, but if you saw that, you probably identified a number of game changes. But these are not just game changes. They're in fact reflecting that the game is changing. And so how do we and what do we do to not just be a recipient of game changes, but in terms of changing the game? And how do we leapfrog? And how do we become practically radical that enables our graduates to not be asleep, not just be modulated by modules, but in fact implement a number of our modules into scenarios, such as through the example of engineering projects in community service, emphasis on partnerships, people, peace. There is a proverb that I bring forward from the World Federation of Engineering Organizations, WIFIO, and this is a nice quote, which is that give a person a fish, you have fed the person for today. Teach a person to fish, you have fed the person for a lifetime. However, today's global economy requires something more, which is that teach the person how to process and package fish for export and market it, and you have stimulated economic development. So it starts to bring about and it starts to stimulate engineering curricula through stimulus that enables an economy. Now, if we go back to our example of water, but before I deal with water, let's deal with electricity since we are closer to it. If you look at the African continent and you look at electricity, you find that large parts of this continent at night is dark. South Africa, some activity, West Africa and North Africa, usual suspects, Tunisia, Egypt. And we then recognize that electricity hasn't moved as quickly as compared to perhaps mobile phones. Yeah, of course, mobile phones too also need to be charged, but they can charge differently. They can solar charge, for example. But maybe because this technology, mobile phones, the way that the technology propagates, it propagates through a decentralized model. It propagates through these antennas which have to be put into different places. And maybe the decentralized model has enabled this mobile technology to flourish more than electricity. I know that when I was a student in electrical engineering, what I was taught and at the time was how do you communicate, or how do you bring, from a source of energy, electrical energy, how do you transmit this, how do you distribute this? There was a lot of emphasis from the centralized component. Now, we were wondering earlier today whether there was going to be any load shedding, but fortunately it's been warm enough. But in case we did have load shedding, and a number of us have felt the impact of this, and what have we done? We've said, okay, let's not rely completely on centralized solutions, let's have some off-grid solutions. And we have said that, perhaps we have said that only when we were shed through load shedding. Now, if we think about the problem of water, there will be a time when we're moving from 40, we are now at 57%, and when we're moving towards that 100%, we would realize that the solutions that we are seeking is not only about centralized dams, but we're looking at perhaps hybrid solutions. We're looking at doing construction that enables for rainwater harvesting without maybe having to first wait for load shedding to occur. I read about the water that is shed in Johannesburg. I understand it's in the region of 30 to 40% of water that is lost through the system, unaccounted for. So one starts to realize that the water is a big problem. And maybe if we think about it from the way that telecommunications strives to reach the last mile, maybe that has some clues in the way that we can attain sustainable engineering, sustainable development. But it is not something that you can leave to chance. It is something that we have to design by way of a series of deliberate activities. I therefore say and conclude that without engineering there can be no sustainable development. Of course, I believe most of you agree with that. And that with sustainable engineering, there will be sustainable development, and that sustainable engineering education can be a strong catalyst and an enabler for sustainable development. But it's something that we have to do, and something that we have to do by integrating into the way curricula works. I bring forward a quote from Dr. Price, which you can read, but I bring forward a second quote, which some of you may have heard. It's not just the Kenako, which is from the World Cup, but it's a quote that says that there are two times to do things. The best time is usually to do things 20 years ago, and if you've missed that, second best time is probably to do it now. Ladies and gentlemen, with those words, I come to the end of this presentation. I'd like to thank you for your attention.
I think what I'll do now is I'll ask the immediate past president, Dr. Payette to come up and give the vote of thanks. He is eminently qualified to do that because he wears many hats, so he can appreciate what was given through today. Over to you.
Thank you, Mr. President. Thank you. Thank you, colleagues. Mr. President, Deputy Vice Chancellor, Mr. Speaker. Firstly, Mr. Speaker, now I would like to say thank you to all of you for gracing our function this evening, for attending and for listening and participating in the 64th Bernard Price Lecture. Thank you very much for giving us your time this evening and for being with us at the Institute and continuing to support us at all times. Much appreciated. Mr. Speaker, to yourself, we say thank you very much, and thank you for adding to the legacy of Dr. Price. The changing conversation that you bring to the table, anchored in Africa, globally competitive. I think you've given us the way forward in terms of building and serving society. Your last message in terms of the purpose of business is well received. We've got to serve society and give to society and to all our people a much more better quality of life than what we have had received in the past. Thank you for that, sir. On behalf of all of us here present this evening, and from all the members that you have addressed across the country, they've all sent the well wishes and their appreciation. We want to give you a small token of appreciation and say thank you for your time and for your energy, for your wisdom, and for your experience.
Right.
Thank you very much.
Thanks very much.
Thank you very much. Thank you, sir. To the Bernard Price family, sir, thank you very much for supporting us and for continuing the legacy of Dr. Price. Dr. Price, a young consultant that worked for Mertz and McClellan, who had come here to this country again with the mandate to provide quality electricity at the best value for the customers, using economies of scale so that engineers could give to all the inhabitants a better quality of life. Thank you for supporting this continued legacy, and we look forward to your support in the years coming forward. Deputy Vice Chancellor and to the administration of the University of Witwatersrand, thank you for hosting us. You do it continuously, you do it with pride, and we are greatly honored to be associated with yourself. So on behalf of Council, I would like to say thank you to everyone for supporting us in this venture. Thank you, sir.